Okay.
Yeah, it looks good.
All right. Good evening, everybody. Welcome to the last episode of vBrownBag for 2022. It is December. We are wrapping up the year just a little bit early. My voice still sounds like I've been gargling asphalt since AWS reInvent, which was last week. I'm still getting over. I didn't get sick. I just got my voice got shredded, unlike Andrew Brown, who got physically shredded, apparently, maybe, or ripped or swollen. I don't know.
He will be. He has the shredded workspace now. Now he just needs the shredded the bod to go with it.
He will be for 2023. So in less than 20 days, Andrew Brown will be shredded. You've heard it here first, folks.
And certified. Certified shredded.
He's certified in everything. He's amazing. All right. So since this is the last episode of vBrownBag, we are going out with a bang. We have an AWS hero with us. Hot diggity damn. His name is Ken Collins. He is a serverless AWS hero. And tonight we are going to talk about the Lambda sidecar pattern for Kubernetes event-driven architecture. We were having a little conversation about this offline the other day, and he was talking about using Lambdas as sidecar. Well, he'll get into it. And I was like, that sounds like an amazing conversation that we should record and have people ask questions about. So we've got some folks in the audience. I am going to ask my standard dumb sysadmin questions about this because that's what I do. But first, before I see, I'm so excited that this is the last episode of the year that I almost forgot to do the show notes. Get in on the conversation. If you are in the live studio audience, I will be paying attention to the Q&A, the chat channel, and snarky comments from Andrew Brown. If you are on Twitter or Mastodon, we will be paying attention at vBrownBag. On Twitter, it's at vBrownBag. On Mastodon, it's at vBrownBag@fosstodon.com because we're all big pro open source happy people here. And this is Ken Collins. If you want to follow him, you can follow him on Twitter at Metaskills. Cool tag, by the way. That was an excellent tag that you were able to grab. I love your hat. Do you have a Fosstodon account? Can people find you on the toots?
They could, but I'm not operable there yet. So
I'm waiting
for Twitter to blow up first.
It takes a hot minute to like get used to it and figure out how like to get everything in. A previous speaker, Dennis Foucher, graciously showed me how to like do the tutor. He started up his own instance and everything, and he hand walked me through like the entire process of getting stood up and what the star means versus what the little boost means and all that stuff. So
yeah, I feel like this is a journey to put Mac minis on my desk again and running my own bind and postfix servers. It's just going to lead to awful things.
a lot of people like the first week they're doing it, the second week they're like, I should start my own instance. And I am certainly not there yet. I have far too much on my plate. Between this and between all of the reInvent videos that I still have to cut, one of which is Andrew's. Ken, we missed you terribly at reInvent, obviously. It would have been wonderful to have seen you.
Thank you.
So yeah, definitely next year.
100%.
Awesome. Okay, cool. Well, so with that, let me relinquish the screens and why don't you take it away?
All right, I'm gonna try presenting a tab.
Mm-hmm. You lost audio again.
And then I can unmute it. So I'm good now?
Okay, yep, we can hear you now.
Cool. Yes, so I think one of the main reasons I wanted to, so first again, my name is Ken Collins. I'm a principal engineer at Custom Ink. That is the t-shirt place, not the tattoo place. Let's see. Also a cloud architect, been there for about 10 years now. Really great place. We do a lot of interesting things. The idea that today's talk is some of the stuff that sharing basically some of the stuff that we do at Custom Ink with our Kubernetes and our Lambda stuff. The idea is I always like to kind of want to see what other people think of these things, right? Like you can always be sort of locked into your own business problems, which are unique, right? My problems are not going to be like your problems. But the idea is maybe if I share, I can learn from others where this might be good, where it might be bad, or anything like that. So that's my contextual disclaimer for this talk today is that this is what we are doing. These are problems that we are solving for Custom Inc. We're highly contextualized problems, situations that may not be shared by other people. That's fine, right? So this may look bananas. It may be a good idea, it may be a bad idea, maybe an awesome idea. It may be a good idea for us and a bad idea for you. But either way, let's talk about it.
Or a bad idea for you and a good idea. No, that doesn't work out.
Yeah. Somebody might find it useful. Right. So let's talk about this. Let me start by setting up sort of the context of where we come from and what we're working on. So I've been looking at how to get off of our AMQP instances. We've been using AMQP for about 10 years. We're primarily a Ruby and Rails shop at Custom Inc. We do have lots of other languages in play, but for the most part, we are a Rails shop. I think we've been using Rails since version 1.0 a long time. AMQP has been in our infrastructure. It's running on an EC2 instance, and it's just, rock solid, but we do want to move to more managed services. About 3 years ago, we started moving everything to containers, some Lambda, some Kubernetes and stuff. So we haven't really figured out till recently how to get that migration off of AMQP. For those that don't know, I'll do a little primer. What is AMQP? It's basically we're using RabbitMQ at Custom Inc. For us, you can use AMQP many different ways, lots of different ways. For us, it's basically pub sub for our domain applications. We split things up into domain services, are mostly a service-oriented architecture where teams own certain domains, usually one app to an n number of applications. A domain application will send events to an AMQP topic. Other applications will bind to that exchange listening to certain keys. It creates what's called a durable queue. Boom, those spin off. And then in Kubernetes, that ends up being some sort of long running polling process. We've seen that before. So we migrated the 10-year-old software that we sort of built in-house to poll those systems on old Ruby gems like the Ruby AMQP. And it just has been going just fine. But we need it changed, right? But more importantly, that emoji's not showing up. These are the basic 3 rules we use at Custom Inc. We're not super heavy hitters for event-driven architecture. We want to be, but for us, it's mainly pub sub. And if you look at these rules here, right, the service owns the data. They publish out what happened, past tense, an event versus a message. Other services listen for those events. And then the main service that publishes the event doesn't really rely on the downstream services. If you know your terms right, this is just basic choreography. We don't really get too much further into orchestration or other stuff, although there are cases of it. For us, mostly we're just doing pub sub, simple choreography, domain events. Again, I sort of share this a little bit up front, but we have to solve a problem where a lot of the software that we have that drives this whole polling process, it's like at least 11 years old. Some of the gems that we are sitting on top of haven't been maintained for 4 years. The protocol itself in AMQP really hasn't, it's rock solid, but it hasn't changed. We now have an active multi-region strategy at Custom Inc. So we're looking for a managed system that is in native to multiple regions. And then we have this really sort of big bet that event-driven architectures are a key part of our future-ready platform, right? They're going to allow us to integrate with SaaS companies like Salesforce, Okta for integration and other stuff, and hopefully getting our data and analytics team more sort of real-time and data-driven. So the question was asked is, can we be cloud native and event-driven with Kubernetes? Much of our workloads are on Kubernetes. That's, if I'm writing an architecture for our systems, that's where our customer is, right? Kubernetes. And we've got a lot of systems built around it, but that's pretty much where we are. So the question I asked myself maybe about a year or so ago is like, with containerization, right? This was an initiative we started off about 3 years ago. Can you take containers, right? Containers are supposed to be portable and use them for an event-driven architecture. And the idea is like, when doing this, is there just sort of a simple, viable way to do it? Like, is it going to end up writing a lot more code? And that code is going to be just as complicated as the cloud stuff, so do we have to like write more code, but we get the cloud integrations for free? And what are the checks and balances there? And are the integrations, say, with something like EventBridge, compelling, right? So basically, I drew this diagram, and the ideas are on these 3 pillars here, right? Like, so we looked at EventBridge, and I sort of classified the value as these 3 pillars, right? Like EventBridge gets all these events that AWS anything moves in AWS, you can pretty much listen to it on EventBridge. You can hook up your own custom applications through SDKs, whether they be Rails, Python, or Node. And then you have all these EventBridge, what are called integrated partners like Salesforce, Workday, Auth0, Klaviyo, New Relic, etc. And then you take the event bus that sits under there. And then I ask myself the question, right? Like, can we take all these containers that we have, primarily Rails on the left, but we also have Python and Node, and hook them up in such a way to where we don't have to build a lot of software? So I sat down and did what any good architect would do, and I built a C4 model. And I did like any other engineer, I just stole the C4 models from AWS. So I drew this little diagram, drew up a nice little business case, and basically took the top part of the box, which is the back then in March, the C4 sort of architecture diagram for EventBridge. The bottom is app flow. There's some relationship there, but basically, and then on the right-hand side, you can see there's Amazon EKS with ECR. And I said, basically, if I can connect that purple line there, if I can make that work, right, where our ECR images in Kubernetes were usable by Lambda, then I can get all this value on the left-hand side from EventBridge, and I can get some potential value from integrations with the AppFlow SDKs. So for example, if there wasn't an EventBridge partner integration and we wanted to get more SaaS events, there's a possibility that we could write our own SaaS connectors with the SDK and connect those back up through our own partner integrations back to EventBridge. But basically the work here is can the purple line happen? Let's talk about what we did there. So for context, this is what our Kubernetes stuff looks like at CustomInc at a super high level. We have custom tooling that's written a GitOps process. We started this about maybe 3-4 years ago. And like every other company, we tried to copy another company. In this case, I think it was Netflix. We're not Netflix, we're not t-shirts, but we basically wrote our own Kubernetes GitOps deployment model. It works really well. This diagram's a little bit hairy. It's basically a sequence diagram that describes the developers on the left-hand side and Amazon EKS on the right-hand side. It's a bunch of little ping-ponging back and forth where it kind of checks things into a GitHub repo. You have a custom applications or CI/CD tools like Circle CI. We have a custom application called Beast that does on-demand staging environments. But pretty much you end up where code is run and checked into what's called a GitOps repo. And for us, that's a tool called Ktool. And at the end of the day, it's YAML making other YAML. And once that YAML lands into a Git repo, it ends up being consumed by Argo. Logically, that flow looks a lot better like this. It's pretty simple. There's a custom tool that we have called Ktool. It has two main functions, a build and a deploy. This is pretty much common in a lot of tools, everything from Copilot to SAM and whatever. The build builds a Docker image. The deploy takes that YAML that's in each project, builds more YAML out of it, the Kubernetes YAML, checks it into a repo, and Argo CD synchronizes it. On the right-hand side, you have EKS, and then you magically end up with pods. So oversimplified, but it just kind of shows the general GitOps flow that we have. So for us, this tool, we have about 100 applications is applied to about 100 projects. So they have a file that's like their own configuration file. It's a simple interface to Kubernetes. Developers don't have to write all the Kubernetes file. They just write the simple interface to Ktool, and it happens in each project. And so each project goes through this process. For us, for Rails apps, at a high level, this is what we're pretty much starting with. You have EKS, you have a single Docker image that's built. You have your traditional web app pod, which is a Rails app that users tend to hit. We have a messaging pod. That's where we use our AMQP stuff, where we get our events and our messaging. Most Rails applications have a background job processing, that's Sidecar. What this is meant to illustrate is just not a full diagram of how all the services at play, like, so technically Sidecar would connect to a Redis database, but what this is showing is the before state of what we wanted to change in our system. And what I'm highlighting here is that if you don't know how this stuff works, basically all these pods use the same Docker image, right? And what's happening on the inside is they have like a different entry point, right? So when Ktool builds the YAML out, we're basically saying for each of these Docker images, the command to invoke is different, right? One would be for the web server, one would be for the Sidecar, and one would handle the messaging, which would do the polling. Same Docker image for each pod. So where we wanted to do is like for the proposal, I tend to work towards the end. Like I'll architect what I think might work, don't know if it will or not, and then sort of work backwards. So the question I asked is could this be what we changed to, right? So if going from RabbitMQ into that messaging pod, and can we pull that messaging pod out and use Lambda with Event Bridge? Same Docker image. That's the goal. So let's talk a little bit. Go ahead.
Because it simplifies the architecture, it makes the spin up time faster, it lowers your cost. Why?
Oh yeah, so like let's say you get built-in first would be a functional interface to your code. So the gems that we have that use AMQP, they basically use closures. In JavaScript, that would be a function, and Ruby, that would be a block to say, hey, when I receive an event for this message, invoke this function.
Okay.
Right. So there's a lot of boilerplate around that code. So what we wanted to do is to maintain the functional interface. We also want to get free scaling, based on queue depth. So the more messages you have, the more functions you can invoke, you get it for free.
Without creating more pods or would it create more, in the old pattern, does it create more pods to increase your queue depth, or
yes,
would you? Okay.
But you'd have to figure out the ratio to exercise your memory in Kubernetes or your CPU, right? To be able to get that scaling to work right. So you have to batch a certain amount. You have to figure out like what's a batch, what makes your CPU or memory go up. And then you have to write your rules in Kubernetes to be able to get that scaling. And Lambda, you would have a direct one-to-one managed scaling thing where you just didn't have to worry about it. The only thing that you would have to worry about is overscaling.
Right. Andrew Brown has said, frigging Sidekick. Sidekick has sidekicked my butt many times. Can we see the old pattern again? I think I blinked and missed it.
Yeah. So here's the old pattern. Basically, we just want to take that messaging pod and we want to pull that out into Lambda somehow.
Right.
Let's talk about how we get there. So for this to work, we really have to do something, right? This is the purple line. This is like in the diagram for the C4 model. If we can get to this, the purple line works. So there's two things that really sort of do that. But first, what I really want to talk about is like what's really happening under the hood, right? It's not just a Lambda with Event Bridge. For Event Bridge to work, right? So that little box down at the bottom, you need an Event Bridge rule. That rule should probably go to an SQSQ. In our architecture, it's needed, and I can explain a little bit why. And then that SQSQ would hit a Lambda function. And then there's also a DL queue. We sort of get this for free with AMQP because they're called durable queues. So if like the Kubernetes deploy went bad, messages would sit in that durable queue up until infinity, until the application spun back up again to process it. I'll talk a little bit about how this architecture is hardened to sort of give us that type of interface. But the first thing I did is like, let's take a look at the YAML that we have in our project files, our KTool file. And I wrote this up. This is the interface in KTool for the developers to migrate and use Event Bridge. It's really basic. YAML drives everything. In this case, we provide a YAML interface to where they can create n number of Event Bridge rules. They give it a name, which ends up being a physical name for the CloudFormation resources. They give a bus to listen to. There's a one-to-one mapping here on the pattern source that Event Bridge rules can bind to. And then they basically provide a command inside of their application, a function to invoke once this message comes in for this Docker container. But to make this happen, you kind of need a couple things. But if you remember, this is the GitOps process before. So we're going to approach this from a GitOps process first. What do we need to do afterwards? And this is what we ended up with. So basically, we've hooked into our GitHub deploy repo. KTool will do the same thing it has always done. It'll build YAML from YAML, but now it's going to actually build a CloudFormation YAML as well as part of the Kubernetes YAML, and it's going to check that into the deploy repo. And if you see that little bottom line there that says GitHub Actions CloudFormation Deploy is what the CF stands for.
And that,
so
and
before,
that builds your Lambda.
Yeah, that builds your CloudFormation stack.
Right. Okay.
So let's talk about that CloudFormation stack and how can Lambda use the ECR repo up above? And then what maybe is in that CloudFormation stack? So there's those two lines with Lambda containers now, and I can dig into those a little bit. So the first one is how can Lambda use Kubernetes? The next is how can the GitOps drive the process? So let's talk about how can Lambda use an image that you built for Kubernetes. Well, if you looked at the diagram that we had where we used the different pods, we had the web pod, we had the messaging pod, and we had the Sidekick pod. Those are all the same Docker image. The only thing that was changing was the command. So if you looked at the Kubernetes files, in this case for us, we can actually, Lambda has what's called an image config for containers. You can override the command, you can override the entry point and the working directory. The first two are important for us. And how do you do that? Basically through the RIC. So AWS Lambda has a thing called the Runtime Interface Client. It's called the RIC for short. There are many different RICs. There's RICs for Ruby, Python, Lambda. They're all specific. There's a whole council of them. And they and they basically, you can install them in any Docker container. And that becomes your entry point. So if you look on this command.
I'm so proud of you for putting in the council of RICs in there. I'm tearing up here, Ken. This is amazing.
Yeah, you just got to figure out which one's Node, which one's Python, and which one's Ruby. Right? Yeah, no, Ruby's the weird one, so I'd say it'd be the flock of seagulls or something. But anyways, so once you install the RIC, you have an entry point, and that entry point is going to be your contract for Lambda. It'll do everything for you. You just hook the entry point up to it. So for us, that basically means that in our Kubernetes images, we'll install the RIC at some point, right? It's only a few megabytes. It's a little bit more complicated for Node, but there is a GitHub issue to make Node really easy. And then I'd like to sort of point your attention to the command. So I don't know if people have ever done this before. We're used to doing things like app.handler or other things in Lambda functions. The command can actually be pretty more intense than that, right? So in this case, you can actually provide it a file path. And whether it's Ruby or Node, it'll find that file path and load it. Rails comes predefined with a single file that'll load up your entire Rails application. It's called a config environment. And once you hit that file and load that file, your whole application is ready to go. And then everything after the dot there, since it'll be different, right? So for Ruby, every method that's within the application is globally accessible, right? You don't have to do exports or imports. But basically, this would be the function handler. So in Ruby, you can just give it an active job, perform now. So with like one line of code, you don't have to do anything. You can tap right into a Rails application. For Node, you'd probably have to have like a single like index file or app file, maybe a startup express, export a function, but the interface is still the same. The command for the RIC is really, really powerful. So the other part of that, we talked about how do the containers get used. So this is what the snippet looks like in a sort of full working example within our GitOps process. It's basically a CloudFormation template. It'll go through and add some other AWS resources, but the Lambda function would look pretty much like something like this. It would take the image URI, point it right to the same Kubernetes image, override the command of the entry point, bingo, bango. Your Kubernetes image can now run on Lambda. And then you end up with this. So then how can we do the GitOps process? So that did two things, right? How can we use the container and how the GitOps process works. So there's a GitHub action. It's only about 100 lines long. It's basically just a SAM deploy or SAM delete. Pretty simple. Mm-hmm. So there's a couple gotchas with this, right? Like it can't be that easy. And you're right. There are a couple little gotchas. So one is secrets. So if you use Kubernetes, you might be familiar with something called the Kubernetes secrets operator. And that is basically, it would hook up to something like Secrets Manager or SSM so that you could have environment variables inside of your container that are backed by SSM params or paths. Now, this pattern that we've been using, it would not be acceptable if the engineers had to go inside of their code and change how their environment works. And if you've ever dealt with Lambda and environment variables, you know there is a plethora of solutions that say, hey, you can get SSM-backed secrets if you just change your code and do all this stuff, or you install an extension and change all your code to hit this service on localhost or something like that. To me, that is not acceptable. So I wrote a little Rust project called Cryptia, and it uses, you can use this on Node, you can use it on Python, you can use it on Java, you can use it on Ruby. You would install Cryptia, and you could use it on Lambda or any Docker container. It doesn't matter. It's using an LD preload thing, and it will basically make sure that whatever programming language you use, when it goes down to the system at the libc level to get an environment variable, it'll get the environment variables that are fetched in memory from SSM when the application process or the initialization process starts up. So none of the container code has to change, and you get magically, it's basically Kubernetes secret operator for any Docker container. The other part is the AWS resources. So just to drill down to those a little bit, this is the basic thing that we would stand up for the engineers for each of the rules. If you've ever dealt with AWS resources, you know they can be a little bit, you can sort of configure them in different ways. And we had to harden ours to get a behavior so that we could sort of provide as much feature parity as we could with AMQP. So in this case, we basically used a configuration from the event bridge rule to the SQSQ that gave us the this AWS sort of what I call these implicit or implicitly created AWS resources, these redrive policies. So in our situation, with the configuration from event bridge to SQS, we get a full sort of exponential back off, 24 hours, 185 retries. If AWS ever goes down for any reason where the event bridge team can't talk to the SQS team, that'll ensure messages get there for us in a way that they back off, or they eventually, after everything fails, after 24 hours, they end up in the DLQ. AWS is really good at keeping the good stuff to themselves. They don't have a configuration for the SQSQ to Lambda to do the same thing. You can hook into it a little bit, but we basically mimicked a 5-minute, so each function has 5 minutes to do their work. It has a visibility timeout of up to 6 hours, which gives us 72 retries. We don't get the exponential back off. There are some features we've asked AWS to change in how the redrive policy works to give us the good thing on the left-hand side, the exponential back off, but this is what we have. And if you explode it out for, let's say you had listened to 2 buses, 2 rules for 1 bus, 1 rule for another bus, this is what the diagram would look like. And it basically means, from a change management perspective, engineers really should never have to operate with a DLQ, but we have monitoring processes. We have new things where if they ever did end up with messages in that DLQ, maybe they had a bug in their code for 6 hours, there's an easy way to push a button and drive this out. But this is, the architecture gets a little bit neat when you look at it in detail. And in the end, again, we've ended up with something like this. And in actuality, this is what it looks like. So each project now is able to create AWS resources through our internal tooling. The Lambda sidecar is a key part of that tooling. It's not the whole picture. And the cool thing is that our internal tooling is a little bit more mature, like other tooling, where we can start to say, hey, engineers can now have resources stood up for them in their KH projects. It's not just compute anymore. It's actually tapping into the resources for the cloud. And I happen to love that very much. I think that's pretty exciting.
Nice. Okay. So a couple of different questions. So you previously, obviously, or well, actually, no, I was going to say obviously, but that's not the case. So you maybe had monitoring in there ahead of time, where you were monitoring the performance of the sidecar before it was turned from a container into a Lambda function. Did you notice like performance increases? Did you have to modify your monitoring parameters to measure the performance from the new environment? Was there? Yeah,
that's a good question. So monitoring for us is mostly New Relic APM.
Okay.
And the only thing we had to do in our active jobs is to make sure that we flush the New Relic data before the function finishes. So this wouldn't be acceptable if it was a web request, right? Because you would say, hey, I'm not going to respond completely with the web request until I talk to another service provider, because that normally happens asynchronously in a full running process. So there's a little bit of glue code in our jobs that makes sure that New Relic flushes the data out. The cloud formation that's generated on behalf of each function or each event bridge rule runs at 1,792 megabytes of memory, which is 1 virtual CPU, which is more than we let the Kubernetes pods has, because we squeeze those really tightly, for some apparently reason. And even at 1,000, Rails doesn't need more than 1 CPU when you run it in Lambda. That it's just a waste, right? So like you just give it 1 virtual CPU, and even though that's more memory than we would give it in Kubernetes, it ends up being cheaper because we can scale to 0. I call it Lambda's like this proverbial sand, right? When you do the jar, like if you had to fill the jar up with sand, pebbles, and rocks, right? Like Lambda is the sand, right? And you can just pack a lot of density, and the utilization is so good on it. So it's going to be way cheaper. In fact, I think one of the first services that we moved over there was like $1 for a month for all the jobs it got from the merchandising system.
And before that, it was
Nobody knows how to measure Kubernetes costs. Nobody knows. They'll tell you, but it's all best guess, right? Because
it's unknown. Who knows?
yeah.
Nice.
But did that answer your question, Chris?
Yes.
Like,
yes,
so
it did.
from the engineer's perspective, nothing changed, right?
Right.
They just looked at New Relic and they see the transactions, and because it's an active job, it's the same thing before and after. And there's no speed loss, there's no performance loss. In fact, it's better.
That's awesome. And Andrew with the snarky comment, just use Red Hat OpenShift. Boo, boo, Andrew Brown. Bad. No donut. I should light up his mic just for him to be a big jerk. Cool. All right. There's a lot of other dumb questions I could ask, but this was absolutely fantastic. I love the way that you broke it down. The way that next steps, are you going to Lambdify anything else, or is the end goal to fully break this apart, or what are you going to do with it next?
Well, we've got a longer tail adoption to where we sort of roll this out to more of the teams and the different parts of the business running it on the platform. There could be some weaknesses in this, but we haven't seen any so far. What I would really like to see is taking that Sidekick stuff and doing the same thing. So
replicate the pattern with other applications.
Well, so let's go back to this image right here.
Mm-hmm.
So our messaging architecture doesn't have retry logic. And we need a little bit of that. So every RabbitMQ message that hits that messaging pod immediately creates a Sidekick job to get the exponential backoffs and retries that Sidekick gives us. So there's a double tap on CPU utilization with Kubernetes, right? So on top of Kubernetes being hard to measure, we can't really tell you how much we're paying for the EC2 instances for Kubernetes to run this mixed behavior for that pod, send to that pod, and how much of that pod is sending into the other pod.
Because of the hairpinning.
Right. So if we were to finish the migration off of the messaging, we could have a clear line of sight into how much cost per team, per application, the messaging costs, right?
Right.
And we're able to in our active Northern Virginia, Ohio region, like to just have like scale to nothing architecture. At night when no things are happening, nothing's running and stuff. I'd like to see that happen for Sidekick too, because those are long running polling processes, right? So we kind of talked a little bit about like what AMQP is for us. And that purple stuff really bothers me, right? The fact that you have to have like something constantly running and polling, even when there's no work to do, just kind of drives me nutty. Yeah. And I'd like to see that applied to Sidekick as well. There.
Nice. Very cool. One last super stupid question. The C4 paradigm that you mentioned at the beginning of this, obviously not an explosive. What is the C4 paradigm? I'm not familiar with that terminology.
Yeah, so we it's basically a way to communicate architectural diagrams in a standard format that starts sort of from big, 4 phases, right? So there's the system phase, I think the component phase, I have to take a look, a container phase, and then a code phase, right? So like at the top are like your systems, right? Like, and systems could be, here's the design system at Custom Ink, or the merchandising system, or it could be something like, here's the event bridge system and other stuff. I was like, oh yeah, and I dropped into my cloud. But it's basically helped us at an architecture team at Custom Ink to know which level we're talking about. And it's just, I think it's like systems, containers, something else at code.
And code. Okay. That sounds very similar. So in my brain, from the systems admin EA brain, there's this thing called TOGAF, and it's conceptual, logical, physical, and financial design models. So it sounds very similar. Just there we go. Yeah. Something for me to Google later.
Yeah. So there it goes. It's the context, containers, components, code.
Nice. Cool. So it's effectively like it's TOGAF for code.
Mm-hmm.
Nice. Cool. Well, let's see if anybody's got any questions in the Twitter sphere or, oh, nope, talking about t-shirt swag from reInvent. No, let's see if Andrew was toe. Oh, geez, what a knucklehead. 5K USD to run Hello World. It's just snark from Andrew. You know, as a Canadian, you think he'd be much nicer. He's not. Now that he's lost, now that he's like lost a bunch of weight and he's just eating oatmeal, he's super irritated.
All alone in his little house that he's built for his.
I'm totally lighting him up though. Let's drag him in here.
I don't know what you expect from me.
Andrew Brown.
Yes.
Good evening. Good evening, sir. How are you?
Oh, great. But sorry, yes.
Are you back home and not sick?
Yeah, I'm less sick, I would say. I mean, you know, every day is a bit different for me, but yeah, and you know what? I mean, like, I guess just like when I don't have to talk, I can be really nasty in the comments. And I really should apologize, but
it's fine.
My alter ego.
You know exactly how dark and cynical I am after spending a week with me in Vegas. So perfectly fine, dude.
Sure.
You absolutely need to change your profile pic though. That is old Andrew.
That's bloat Andrew right there. But
that was nice. I said old Andrew.
That's okay. I know what I looked like before.
Yeah, now you got like facial hair.
He's like he's like you know how when they took Batman and they went all dark and gritty. He's like the Batman Andrew now. He's like dark and gritty and scruffy. He's like the Chris Nolan Batman now. He's the Chris Nolan of Andrew Brown's.
Oh, I was kind of Team Edward for Batman.
Team Edward.
Edward Norton? I mean, no. What's his face?
The Sparkle from Twilight.
Yeah. What's that guy's name? I can't. Not Patrick.
I don't know. Actors keep using different names. It confuses me.
Yeah. No. Sparkly Twilight Batman.
Yeah.
Which was actually a good movie. All right. We have gotten way off topic here. Ken Collins, AWS Hero. Thank you so much for coming on the show.
I appreciate you, Chris. Thank you.
As always, it's a pleasure talking to you. And I super appreciate the fact that I was going to ask more questions about the different functions and services, but you had the foresight to put URLs in almost all of your slides. So after this, I will go through the deck and I will take all of those URLs and I will put them in the show notes so that when people have questions, they can click on the link instead of harassing you at home in the middle of the night.
And I'll send you a copy of the deck too. And as always, like this is just the start of the conversation. So like, reach out on Twitter, tell me a little bit more about your ideas, like neat conversations around like, what were the alternatives to this, right? Like, one was Amazon controller for Kubernetes, which could stand up all these resources for you and even do different stuff, right? Like there's new managed ways to run like daemons, like you used to do back in the day with Elastic Beanstalk. That could have been an option. And there's Argo events and trigger mesh and so much more under the hood here. So if it's something that's interests you, if you like events, if you like containers and you want to talk more about it, I'm happy to hear of it.
Oh, you know what? I misclicked on a button here. Andrew Brown actually did have a question, but he's muted himself now, so I don't know why he didn't just ask.
Well, I can unmute at any time. I mean, I have tons of questions. Like, I mean, the term sidecar are these sidecars right, or is there I don't know. Like, I guess it's more like I always thought sidecars were like a container that like sits in front of your app and filters stuff out, kind of like middleware.
It's not the right it's technically not the right term.
Oh, okay. So yeah, but I don't even know what you'd call this, but it's just like, but I understand what it is. It's like Lambda. Instead of having to
Lambda pods.
Yeah, well, instead of dealing with a bunch of pods, it's like, let's use managed Lambda and it makes our lives a lot easier. But I guess the question I was wondering, because when I was investigating like using EventBridge as an event bus in kind of a similar fashion with our rickety old Rails app, I thought there was like service limits up to a certain degree. So is it that like those service limits aren't an issue because of the throughput? Or is there a concern at some point that you might outscale those limits? Maybe the limits have increased. I'm just thinking about really old EventBridge limits.
Yeah, was that like is that the one where it's like you can only have a certain number of targets are rules.
I think it was like, I thought it wasn't just rules. I thought it was like throughput of how many events you could have per something.
Yeah, I think when, like, if I look at custom inks events, we're only doing, like 30 a second, right? We're not really heavy hitting. Like, we've got a lot of stuff that gets pretty active and a lot of chatter, but our usage of events is not enough to warrant like counting event bridge out. And if we can run customink.com on it, then I would wager a lot of people can probably use event bridge too. But that is a valid question. But I don't think we're anywhere close. Or I have more research to do, but I think we're good.
With all this architecture that you have, it seems like you are primed to launch your own Mastodon instance, since it uses Rails and Sidecar and stuff. So, when are we gonna see you get us a nice, resilient, reliable, and trustworthy Mastodon instance?
Customink.social.
Yeah. What would you call it? Customink.social?
I guess .io, right? We have the .io domain. We should use it. Everything cool is in IO.
And is there any reason I mean, are you using Sidekick, or have you thought about like
Yeah.
using SQS, or is it just because like Sidekick's so darn fast?
It's change management, right? Like Sidekick is fine, right? It's not broken for us. It has broken down for us. It does require, getting alerts off of it and dealing with things. But I'd like to. We're not going to save a ton of money by moving Sidekick over to Lambda. We're not saving a ton of money by moving messaging over. So it's more just being intentional with the change management, and cognitive that when stuff like this rolls out, you do have teams that at some point need to know how all this stuff works, right? And there's a balance there, right? So like having your compute split across two different container systems could be a problem, right? If you don't build enough tooling for the team to sort of manage it away, or just sort of like keep them from it, right? So it's I don't know if that answers your question or not, Andrew.
Oh, sure. Did you ever get to play around with KEDA? Was there any like fit in the architecture where it might have, because now that you're on like Kubernetes with pods and stuff like that, was that ever evaluated? I just like interest in general.
Oh, that's the first time I'm hearing about it, so I'm Googling it right now.
Yeah, so it's like KEDA, Kubernetes, event-driven architecture is a way for you to, I guess, implement event-driven architectures in your pods and stuff like that. I
Mhm.
don't know if like you can plug it into other stuff. So like over in Azure, they have synergies with KEDA outside of just Kubernetes. So it
Mhm.
makes me think like maybe you can, I don't know if it'd be possible to like wire Lambda to do that. Probably not, because it would have to be a layer above it. But anyway, yeah. So there seems to be some kind of system there. So I don't know. It's just because you're mentioning EDA earlier. I was thinking KEDA.
Yeah, there's a whole nother topic about like say cloud events, cloud events.io, which I think Trigger Mesh or maybe Argo Events is built on top of. Um, there's a future in EDA where we have to get better at it, and that's going to involve not just events or messages, but also streaming. And that's not Event Bridge, right? So there's a whole bunch of things like this is part of the solution. It's not all of it. And we're still in the shallow end of adopting an event-driven architecture. Phase one is just getting off of AMQP into something that's a little bit cloud native and may have more for us in the years to come.
I got more questions.
Good.
Well, I mean, like for me, it's just like the architecture, the technology. So, centered like similar to what I like to use. So I have overflow questions. Did you ever get a chance to look at like Knative or OpenFast? Because like, Ken, you've always been like leaning towards modern application serverless, and because you're running Kubernetes cluster, I wondered like, well, did you look at those, and what did you think about those? Or maybe they're just like, they're interesting, but no time, and it's easier to work with containers, more robustness, or.
Yeah, I think the reaction is every time I crack open Kubernetes, and I'm not a Kubernetes expert, is that it's just it's just a gift that keeps giving, right? So when you try to do something simple with it, like the Amazon controller for Kubernetes looked really fascinating, right? But like to implement that, I don't know. Am I still sharing my screen?
Yeah.
So if you look at this picture right here, and you're really critical of it, you would go, okay, there's a problem. And those two bottom lines that connect the deploy repo to their individual container hosting things are disconnected, right? Like in theory, you could have a deploy go out and it's running fine on Kubernetes, but it's not running fine on Lambda. And there's different ways to connect that up, right? You could be very frugal and you could do something clever with the Kubernetes API because it's amazing and extensible. And you could sort of tie those two pieces of state together, right? And sort of synchronize them, if you will. That's like a judicious hack that's appealing to me. But when I look at things like, say, Amazon Controller for Kubernetes, and I haven't looked at all the things that you said, but let's say I did dig into that one and even asked the team that had experience with ACK, and it was just like, oh my God, we would have to do this and we'd have to do this. And I was like, well, how do we get scaling based on QDEP? And they're like, oh, there's a solution for that in Kubernetes. And it's just more stuff you have to do. And generally, the team is interested in not doing that stuff.
Yeah, well, domain knowledge of the team and what they want is more important than just jumping on fun new tools and
Yeah.
shoving them around in the pipeline. It's just like when you look at, it's like we're in a space where it's like you have Kubernetes, and it'd be so nice if there was a service layer, but then you still have to manage Kubernetes. Like that's the issue with Knative and OpenFast, and then it doesn't exactly work as nice as Lambda. But then you might as well like just use containers. But then we've been hearing, at least I've been hearing, because everyone's pulling me aside for the new compiled serverless frameworks like Wing or Amped, or I don't know the other one, Nitric, where the idea is like you can just deploy, like you just write your code as you would, and then you just say pick the target, this provider, and then you're there. Right. And then you get all the batteries, all the managed components. But it just seems like, I don't know, maybe the industry's still figuring it out, or maybe it's just like there's a certain level of complexity and it's just like you're going to live in Kubernetes. I don't know.
Yeah, I'd like to write an adapter one day where like all of our Kubernetes projects just magically go to Fargate or something else, right? Like I just want everything to be as managed as possible. And there's a lot to go there.
I had one more. It's not a question, but it's more like a wish. It's like, I wish you make a in-depth talk on how you did your pipeline, because like the CI/CD, like I saw you're using Circle CI, and it's just like I spent months trying to figure out, like with Argo and like maybe Jenkins X, but you can use Circle CI. I'm just like, it just racks your brain trying to figure out a good CI/CD pipeline, and it's just, I don't know. I'd like to see it as a future wish.
Yeah, let me see it. I think like we have a whole team of engineers in Prague that built a lot of our Kubernetes and CI/CD stuff. They're brilliant, and I'd like to coerce one of them to talk about that stuff more, because it is custom, but it's incredibly powerful. Like we have these really neat ways that we can do on-demand staging servers and stuff, and it's just one of the tenets of a principal engineer that's listed on AWS, I try to like exercise, which is sort of respect what came before, right? Dogmatically, I like Lambda, but like we're on Kubernetes and we have a lot of custom tooling for it. So I really appreciated the work that team has done with our Kubernetes and our CI/CD stuff. And it is bespoke, it is in-house, it is, there's probably things that you could buy now that would do it as well, but maybe not. Maybe it is pretty good. It's not open source though. And I'd love to see them talk about that a little bit more, because it was easy for me to platform this type of innovation on top of it. And that's something that I've thought that I think maybe that AWS could learn from as well, right? They talk a lot about wanting to help us not write so much connective tissue, right? But if each of these sort of container systems are just going to keep doing, like if Kubernetes is going to end up doing, like with Argo events or ACK, what Beanstalk was doing, right? There's got to be a way that maybe some way that their projects can start to take advantage of the ecosystems that aren't in theirs, right? Like, why does it always have to be all Kubernetes when you're in Kubernetes? Why does it, it feels like it keeps setting barriers up for that stuff where they talk about like the analysis paralysis of I'm a customer and I want to come there, right? Like I have to pick the right one because I'll be in that ecosystem. And I'd really like to see the platforms become more unified. are tacked towards a single solution.
Well, I think the community would appreciate, like, I was trying to look up K tools, and it's like hardware, or like for construction, and there was like Kindle, like some kind of Kindle app, and I'm like, what K tool? So, I mean, these tools obviously exist, but the content's not being out there. What you mentioned about, like, does it have to be all like Kubernetes? One framework's called Dapr, DAPR. By Microsoft. I haven't figured it out 100%, but like the promise there is like you plug it in and you use your compute, and then you have adapters out to like all the managed cloud services that are around it. But I mean, like, it's really just for Microsoft, like Azure. Like that the promise is like anywhere, but it doesn't really deliver, at least from what I could tell. So yeah, it'd be nice. Like, I don't want to do everything Kubernetes. I want to manage as much as I can. As long as it's vanilla, and if I had to take it somewhere else, I mean, if you don't have to, you're lucky, but like I have to go to other clouds. So yeah.
I maintain that everything's portable, right? Like if I could take a Rails app and put it on Heroku, put it in our Kubernetes stuff, and put it on right, Lambda, everything's portable. It's all the CI/CD, right? I think is what you're alluding to.
Yeah.
Cool.
All right, gentlemen. Thank you very much, Ken Collins, AWS Hero, for coming on for our last vBrownBag of the year. Andrew Brown, thank you for popping in and putting in your 2 cents Canadian on the the last vBrown. Hey, did you get your children's Tylenol?
They let me through.
They did. Awesome. Good. I'm glad to hear that. So Ken, we part of the vBrownBag AWS interview the interviews that we did this year. We asked 2 questions. One is what do you want to hear about when you get here to reInvent? The other one is what do you want to leave with? Andrew's answer to the second question was children's Tylenol, because Canada is currently having a shortage of children's Tylenol, and so he, like a drug mule, carried as much children's Tylenol with him as humanly possible across the border, successfully, I'm happy to say.
Well, I hope he has a child.
Well, that's the weird part. He doesn't. It was kind of weird. Maybe I don't know. Some kind of
reminds me
scenario.
of the Call of Duty operator skin I had to buy because they didn't have the Burger King special in America, so I had to buy it off of eBay from somebody in Europe. It's like
the liquid just gets me through the day, to be honest.
That's how he rolls. That's what he needs. All right, folks, have a wonderful evening. Ken, thank you once again for coming on the show.
Thank you all.
And I will be seeing both of you either at reInvent or sooner at the Seattle Heroes Conference.
Heck yeah.
So
thanks, Chris.
Guys, have a great night. Cheers.